Alright guys, so it's been a while since I actually went ahead and I did a video on just a waveform of the component onto a vehicle. So what I thought I'd do in this one is we'll take and look at an injector waveform together. Now I'm going to try to go through this into a timely manner, and I'm going to try to go through each point from A to Z on what you should be looking for when you're looking at an injector. So the test that we're going to be performing is on the saturated style injector. Now there are two types of injectors out there. You got a peak and hold style injector and you got a saturated style injector. One of the main differences between the saturated style and the peak and hold is the amount of resistance that the injector actually has and the way that it's operated by the driver of the PCM. So on this one, basically we should have a high impedance, like 12 to 17 ohms of resistance. And onto a peak and hold, you will have a much lower resistance rating. Now, getting back to the saturated style injector, what we're going to be doing basically, I'm going to run you through a few simple tests that we could do to verify the wiring of an injector. And then after that, we're going to hook up a scope and we're going to see the functionality of a known good injector. Now, I wish I had a bad injector to show you guys, but I don't. It's very rare to actually get a chance to use a scope onto an engine working in a dealer, or engines are pretty much brand new and they don't really fail that often. So what I'm going to do is try and show you guys what a known good is, and if I ever get a chance, I'll show you guys what a bad injector looks like. So the first thing that we're going to do is we're going to go through how to quickly identify the wiring onto your injector. Now on
fuel injected,
you have two wires going to your injector, and what we're going to be doing is basically looking for a wire that is the same color, and then we're going to look for a wire that is different color.
So using this type of procedure isn't always the best, because sometimes you actually do have wiring colors that are different onto each injector. So it's highly suggested that you take and you use a wiring diagram to identify the proper wiring colors.
Now if I come onto this, I don't know if you guys are able to see, but this wire's pink, this wire's pink, this wire's pink, and this wire's pink. But what that's telling me is that the pink wire onto my injectors is actually the power feed to the injector when the key is turned on. And every other color wire is actually going to be my control wire from the PCM. So the first thing that you want to do whenever you're doing a diagnosis onto an injector is that you want to take and you want to verify if you have good integrity of your wiring. Now in order to do this, there's a very simple way. One, you could always take a Noid light and stick a Noid light in, and you could test for control by using a Noid light. What I prefer to do is actually take a light bulb, hook it up onto the power side, and then hook the other lead from the light bulb up to the ground and see if it illuminates. Now, an injector typically takes about 1 amp of current in order to light. So anything that draws 1.5 amps, 2 amps, 3 amps will be more than sufficient to test the wiring for your injector. Now, after that, what I like to do for the control side is I'll take a LED light and I'll test the control side with an LED light quickly to verify if I have control coming from my PCM. Now, if I have power and I have control coming from the PCM, what that leaves is the component itself. So then that's when I would go in and I would test the component. So what I'm going to do right now, I'm going to show you guys how to verify the power and ground, and then after that we'll go and we'll hook up the scope and we'll look at the injector signal. Alright, so I have everything to test the power side of the injector. So the first thing that we're going to do is we're going to take our light, okay, and after that we're going to take and we're going to unplug our injector. Now you gotta be mindful that not every vehicle is going to be the exact same, and sometimes you won't be able to get to the injector connector. So you're going to have to figure out another way in order to test it. Test the power coming from the injector. If you can get underneath, great. If you can't, you are going to have to figure out another way in order to do it. So After that, we're going to take our ground. I'm going to hook our ground up to our ground. And then we're going to take a power and hook a lead up to our power side. Then we're going to take our light bulb, which is right here. I'll keep that in. And all I'm going to do is I'm going to go cycle the key, and we're going to test for power. So as you can see, that light bulb is nice and bright. So I really don't think that there would be an issue onto the power side onto this vehicle. Now you got to remember that this is a brand new vehicle and there is no issue onto it. Now the light will stay on until the PCM turns off. So after that, what we're going to do is that we're going to take and we are going to plug our injector back in. And now what we're going to do is we are going to take a T-pin or a back probe of some kind. We're going to put that in. Now, use of a LED test light is highly suggested for this one, just because if you use a incandescent, what you can actually do is that you can actually round out the injector, which is not what you want. So use an LED test light. What we're going to do, we're going to take the test light, we're going to hook it to battery power. Now, why are we hooking the test light to battery power? Is because the control from the PCM is ground onto this vehicle. And then all we're going to do is we are going to insert it. And then we're going to take and we're going to switch the vehicle on. Kind of lost that. And as you can see, we have a nice little flash going on. So that's telling me that the driver from the PCM is able to control the injector. Now, after that, what we are going to do is, now that we know that our power is good, our ground is good, and while our control from the PCM is good, what we're going to do is we're going to take and we're going to turn the vehicle off. We are going to unplug our connector again. And we're going to take a multimeter. And with the multimeter, what we're going to do is we're going to set it on the ohms range. Now, for this, you need the spec of your injector. If you don't have the spec for your injector, I highly suggest you get it. You can get it on All Data. You can get Mitchell. I think it's about $30 or $40 for a day or two subscription, and you're able to go get all the specs for your vehicle. So highly suggest that you guys get the specs and don't just go off what the people are telling you. So then we're going to we're going to test the resistance of the injector. Now, just because the resistance of the injector is good, would be good, doesn't mean that the injector itself is good. Now you got to remember that most of the specs that you're going to find into a book is with the vehicle cold. I just came back from a road test, so my resistance is going to be a little bit higher onto this one. Okay, so as you can tell, we have 16.4, 16.3, 16.2, 16.1, and it is going to drop as the engine starts to cool down. So far, our power is good, our control is good, our resistance for our injector is good. So maybe there's something mechanical that could be going on the inside. Now, unless you have a scope, there is really no way of you testing to see if for a mechanical issue inside of an injector, unless you physically try actuate it and it doesn't work.
So I want to take the time and put a little side note into this part of the video. Just because you hear mechanical movement inside of an injector doesn't necessarily mean that your injector is actually working. Now, I've come into a situation before where I would see mechanical movement onto my scope, and the shaft inside of the injector had actually broken. Now, this is a very rare occurrence, but just keep in mind that just because you hear or see physical movement doesn't necessarily mean that the component is actually working the way it's supposed to.
But there's easier ways than doing what I just did. What I did right here was show you guys a general way to check an injector if you do not have an oscilloscope. Now, if you have an oscilloscope, there is two things that you're going to need. One, you're going to just need a back probe in order to connect to the injector control wire, and two, you're going to need an amp clamp. Now, with those two tools, you are able to see exactly what is going on with an injector. So, this is what we are going to do. We're going to plug that back in. I'm going to go ahead. I already got my scope set up, and what we're going to do is that we are going to connect to the injector through amperage onto the pink wire, and then we are going to connect onto the control from the PCM with a back probe. So I'm going to set all that up and I'll be right back. All right, so I have everything set up onto the scope. What we're going to do right now is that we're going to go through our settings for our amp clamp. I'm using a ES695 for the amp clamp, and what we are going to be doing is going over to channel C, which is where I have it. We're going to go down to this area. We're going to pick a 20 amp. Sorry about that. Not 200, 20 amp. If I can get to it. Let's try that again. All right, so we have a 20 amp. We're going to set this up to 5 amps because I'm not expecting to see any more than 1 amp onto the system. And that is going to be over here onto the right-hand side. Now, for the for channel A, what I'm going to do is I'm going to set this up to 100 volts because I'm not expecting to see any more than about 50 to 60 volts onto the peak side of channel A. Okay? So I know it's very noisy, but that's just the way that the scope is. So what I'm going to do now is come over. We're going to connect our amp clamp around the injector. I'm going to take my channel A and hook up my channel A also. And we're going to take and we're going to connect our channel A to our control for the injector. Like so. So now I have my current and I have my my control. Now what I'm going to do is just start the car. And we're going to go ahead and we're going to see what we can see. So right now, I'm seeing my control. I am not seeing my channel A. 20 volt position, 100 volts. I'm not seeing the control. Let's see. There it is. Wasn't in far enough. All right. So what we're going to do with this one right now, make sure everything's still working properly. It is very, very noisy. So what I'm going to do is just add a filter to my channel C. I don't typically like using filters because it really distorts the image, but sometimes you don't really have much of a choice. And that's looking pretty good. So we're going to pause that. What we're going to do now is go back until we see it, which is right there. We're going to come onto our zoom. We're going to take and we're going to zoom in onto this area right here. Now, I know that it doesn't look very good because of the filter, but basically, this area right here, if I remove the filter, does line up exactly with the turn off of the control from the PCM. Okay? So, now that I have a waveform captured, I'm going to turn the vehicle off. And we're going to go ahead and we're going to dissect the waveform. Now, just going to move everything. And we're going to focus onto the waveform right now. Now, the waveform, as you see it right here, the red trace is my control for my PCM, and the blue trace is the current that the injector is actually putting out. Now, if we come over here and we come onto our red trace, what we see is that we have typically battery voltage onto our control side. Now, that is normal because if you take and you have a 12 volts coming in. You will have a 12 volts coming out of a coil until it is energized by a ground or a PCM control or something like that. So what happens here is that the first thing that you want to look at is that you want to make sure that you have battery voltage coming in. So you should know what your battery voltage is. So if your car is running and you're supposed to be at 14.5, the input voltage of your injector should be 14.5 volts. Now, what ends up happening at this point right here is that the injector gets turned on by the PCM. Now, you will never have a, how can I put it? You will never have a direct ground, lack of a better word, from the PCM. The PCM will never pull that injector down to ground onto the control side to 100%. So you will never see 0 volts. You will always see 300 millivolts. You'll see 500 millivolts. It really depends on how the PCM is. How can I put it? How the PCM is wired internally and what components that they use. So then what ends up happening is that if we come over here, we will see our injector on period. So this is actually where the injector is actually open. So as it gets energized, you'll see this area right here. Okay, this is your injector on. But as you can see, current starts to flow. The filter really messes up the waveform because it actually turns on exactly where it's supposed to, which is at this area right here. But we see that the current starts to flow. Now when current starts to flow, this little lump right here on the current side is actually your pintle opening. So what ends up happening is that when your pintle opens, fuel starts to spray. So current gets pulled, it opens, and then fuel starts to spray. So your on time is from this area to this area, but your pintle open time is only from this area right here to this area. Then what ends up happening over here is that the PCM takes and it closes or it shuts off the control side for the ground of your injector. And what we see here is that we have a spike in voltage. And I have roughly about, 52 volts, give or take. And what that does is that it spikes up because of the collapse of the magnetic field. So if you would not have the magnetic field and it would just turn off, all you would see is right here, we would come back down to battery voltage. But since we have a collapse of magnetic field, that induces more voltage into the system, which then creates a larger spike. Now, the clip at the top over here is actually caused by a Zener diode.
So it's important to note that Zener diodes onto an injector are used for voltage suppression. So depending on what the engineers decide that the proper amount of protection needed for the system, they could set the Zener diode to cut off at 50 volts. They could set it to cut off at 25 volts. They could set it at 70 volts. It really depends on the engineers. So you can't go off of the fact that this waveform here is at 55 volts, that all injectors are going to have 55 volts. You really need to verify known good and then test the bad one to see what is going on.
Basically a current limiting diode. So it allows it to climb to a specific voltage and then it cuts it off at that voltage. Now that is typically to protect the internals of either the injector or to protect the internals of the PCM. So what ends up happening after that is that we have the dissipation of the magnetic field and the voltage, and then it starts to come down and we actually see the pintle hump close onto the injector side. Now we don't see that onto the current. Well, maybe we would if we would zoom in a little bit more. Well, we can actually zoom in a little bit more. One thing I don't like about the oscilloscope is that I can't turn off specific areas. So we're gonna just zoom into this area. And as you can see, we don't really see a closing of the pintle hump onto that side. So I'm gonna back up one. We're gonna come back here. And then after everything is done, we see our voltage come back down. So it's a beginning point, I should say. So we'll come over here, we'll bring this, see if I can grab this. And I can't grab it. Oh, no. moving that back up. So then we see our voltage come back up to where it's supposed to be. So if we would follow this line, and we will draw a straight line across. I can't get my cursors to work, sorry. We would see that we were back at our 14.5 to 15 volts, which is normal. So that is basically the effects of an injector opening, closing. Now don't forget that this is onto a saturated injector. A peak and hold injector, the waveform looks a lot different. I'll try search online to find you guys a waveform of what that looks like. At Kia, I've never actually seen a peak and hold injector. So if I ever get a chance, I'll take a screenshot for everybody, show you guys what it looks like onto a car and how it operates. But for right now, all I have is saturated injectors onto these vehicles. So that's what I'm showing you guys now. So yeah, that is basically your waveform and dissecting the waveform and using current and voltage parts of your oscilloscope in order to identify where there might be problem areas onto it. So what I showed you is a known good. If I ever get a chance to show you guys a bad injector, I will. And if I would have thought on the Volkswagen that I did, I should have taken a scope reading of that, but I didn't. So yeah, I hope you guys enjoyed this little video. I hope it does help somebody, because getting into using an oscilloscope is key in today's automotive field. There's just too many components and everything is hidden. So the time that it takes to actually remove stuff, you could have already taken all your measurements just by using a scope and moving back a little bit of lumen, putting an end clamp and a probe inside of the connector. So I hope you guys enjoyed the video, and I'll see you guys next time.